All right, going on to section 3 of chapter 9, we're going to deal with these rational exponents, and here they're primarily referring to fractional exponents, as we see down in here. And we'll be doing all of these things, and you can pause and read it if you'd like. Okay, to start us off, and I gave you a little hint of this in the previous lesson, that when we have a radical expression that's in this form, there's our radical sign, there's our radicand, and then this would be the index number. We can actually convert that, and there would be a 1 as an exponent that we wouldn't write normally. But this can be converted to a fractional exponent by taking the radicand, as we mentioned before. The exponent that's on the radicand is our numerator of the fraction of the exponent, and the n, that is the index number, becomes our denominator. And that's what they're showing here. Okay? And they're reviewing words that we've used before. And let's go over this example right here. So if we had the square root of 3, and we wanted to convert that to its fractional exponent. Now remember, since it's the square root, the index number is 2, and we have a 1 to which that 3 is raised. Every number without an exponent is to the first power. So we have our radicand. Our 1 is the numerator of our exponent, and the index number becomes the denominator. So the two are closely related, and we are building toward what we're going to be doing in, I believe it's the next chapter, when we get to logarithms and we use this type of notation. All right, let's go on. Again, you can pause, and we have much of this already in our notes, so we'll pass it up here. And we've done this already. So now we're asked to convert this to its radical form. It's in its exponential form. So we're going to introduce the radical sign. Now remember, this is going to be 49 here as part of the radicand. Our exponent in the numerator is a 1. We don't usually write that. But now the denominator of our exponent is our index number, and we don't write that either. So anything to the 1/2 power is actually the square root of that, and of course this is a 7. Now, again, and it takes a little practice, but I think you probably have a lot of it down. The radical sign, our radicand is 81. Our exponent in the numerator is a 1. Again, we don't usually write that, but our index number is now a 4. Now, the fourth root of 81, and any number to the 1/4 power is a fourth root of something, is 3. And if you don't know how to get the 3, we'll show you that a later time here. And there we see it. All right, now you may know this one already, because it's going to be the third root Having a phone call come in here. Okay, so we'll do this one. So again, radical sign. What will our index number be? 3. And our radicand? A -8. And we don't write the 1 usually. So this is going to be -2. Okay, so I think we've had some practice on this. And we'll be going on here. Oh, let's clear it up so you can see it a little better. And there we go. All right, now, again, this will be the 5th root of this. And I don't need to write it. I think you have a handle on it now. The index number is the denominator of our fractional exponent. And it would be this. Over here. That's because this to the 5th power is that. All right, now keep in mind letter E here as you write this into your notes. This is going to be the square root of a -16. What did we say about that? That it was not a real number. Okay. Now, back in 1103, we did all of these that normally, again, just a plain letter is to the 1st power. Anything to the 0 power is equal to 1, so long as a is not a 0. When we're multiplying variables, we add the exponents. When we divide variables with exponents, we just subtract the exponents. Okay, so these are the different rules we had earlier in the course. And then the power rule, here we multiply exponents. And here the exponent goes by each of the variables. And again, the quotient rule of the power is that the exponent is applied to each part of it here. All right, had another quick phone call, but let's go on here. Okay, so again, there's the general form of the radical exponent, often referred to as the fractional exponents, where the denominator is the index number of the radicand, and this will be our exponent. Okay. Now, one of the things I should mention, in its fractional exponent form, when we convert it to its radical form, again, the n is our index number, the m, which is the numerator, could, and this is the preferred place for that exponent, outside of the parentheses here. And this is also equivalent. But this is the preferred position. So be sure you're writing these down in your notes. This is, for extra emphasis, the idea of writing something, touching the paper, the pencil, the pen, watching it, that helps get this into memory. Okay. Now we want to convert. In some cases I will write things out, but easy things like this, we're just going to use what the book has. So the denominator becomes the index number, the exponent, the numerator becomes the exponent of the radicand. Now you could have written it this way, or you could have put parentheses, put that 2 up there. Now this is critical because you might say, well, I just said something, but now watch this. What is the base of this exponent? And it's just the x. So the 3 is going to go here. The 5 will be our index number, and it will be x to the 4th. So don't make that error of saying that all of this is under the radical sign. Only the item immediate to the left of the exponent, and not the 3. Big error for students. and they're mentioning it there. Now, keep in mind, what is the base here again? Is it a negative A or just the A? And the answer is it's just the A, because theoretically there's like a 1 there. So we put that -1 or just a negative sign there, and then we take the square root. The denominator becomes the index number, and the A is to the 3rd power. Now you don't usually write this 1 there. So we're giving you a little time, if you notice, to copy these down here. Okay, now they want to write this in its fractional form. Well, we're going to remove the radical sign and just take the 6 and make it a denominator of that 5, so you have a fractional exponent. Again, you'll have a 5, and the square root of anything is the 1/2 power. So 5 to the x to the 1/2 power, which is what they're showing here. And I like that they're writing these horizontally, these division fractional bars here. And again, there's a 1 out here. So this is going to be 1/3, a -4 to the 1/3 power. There you go. And they're showing you that, in a sense, it's a -1 times that. Okay. Now, here's where it gets a little bit challenging, and you're going to rely on your fractions ability here. What is the rule when the bases are the same and we're multiplying? Well, the answer was we have to add these exponents. So before you do it, you might say, what will our common denominator be between a 3 and a 6? And if you said 6, that's going to be good. Now, in order to make this fraction have a denominator of 6, we're allowed to multiply it by 1, but our 1 is going to be in the form of 2/2. So 3 times 2 makes it a 6, and then this becomes a 4. And now we have a common denominator. This is just going to become x to the 5/6. One of the rules we went over just a few moments ago here. We went back. There we go. Okay. Now for B here, again, we want to have a protocol, a way of doing this. So we're going to bring our exponent across this division bar, and we're going to subtract it from this. So we'll put a little negative sign here. But what's our common denominator going to be? We have a 4 and a 3. And if you said 12, that is correct. So we have to make this 12s here. So I'm going to multiply it by 1 in the form of 3/3. So this becomes 12, and my numerator now is 9. And we got to make this 12. So the one I'm going to use is 4/4. So this is 12, and this is going to be a 4. So now I just do the subtraction, and I get x to the 5/12. And that is that simplified. Remember, you can always pause and rewind. And they're showing the common denominator, and then finally the answer. All right, now for something like this, we're going to use the power rule. But keep in mind, there's an exponent there of 1. So we're going to multiply by this. So this is going to be 2, 1 times 3, 2 to the 3rd power. And then 1/4 times 3 is a to the 3/4 power. And then we simplify this, and that's going to become 8, a to the 3/4. So not too bad. Okay. Now, this is a little bit tricky. So take some good notes on this. Again, there's a 1 there. So this is going to become 27 to the negative 1/3. 27 to the negative 1/3, but I only want positive exponents. So this is going to go down here as 27 to the 1/3. See, up in the numerator, that would have been a negative 1/3, but moving it across this division bar makes it positive. And then I have here a negative times a negative. And I can do some cancellation, but I'll write it up here. This is going to be y to the 9/10 times 1/3. It's positive, so I'm making these now positive. That stays up. But I can do some cross-canceling. 3 goes into there once, 3 goes into there 3 times. So I now have, as I simplify this, in the numerator, y to the 3/10 over, now this, remember, is the 3rd root of 27, which is 3. And there's the final answer. All right, they're moving this down to the denominator, and they've simplified this. Okay, good. Now, here you need to be careful, because this is in a parenthesis now. This is 1. And this becomes a positive 1/2, which is the square root of a negative 36. When I convert the 1/2 power in the denominator, it becomes the square root. And since this is in the parenthesis, this is not a real number. So they threw one of those in just to check us out here. Good job. And that's what they're saying. Okay. Now, in letter F, now notice this is 2/4. We can simplify that to 1/2. So this is really just 9 to the 1/2 power, which is the square root of 9, which is going to be 3. So again, they're going to challenge you. This is a college course here. Okay. Now as we get onto some of these, they get a little more challenging. But not too bad. So as we look at this, we want to take the square root of 49. That's going to be 7. And we're going to multiply now x to the 6 times 1/2. That's just going to give you x to the 3rd. And now this is going to be y, as we multiply this, the 2's cancel out and we get -1 here, that I'm going to put down in the denominator as just y. Up here would have been a -1 here. I moved it down, and we don't write the 1. And then this z to the 4th becomes z to the -2 as we multiply it by the 1/2, but we bring that up to the denominator as a +2. So this one wasn't too bad. And it is a challenge. And they had a few more steps where they show it in greater detail. All right, now how about something like this? And don't forget to write this as example 4. This is one of our quiz questions here. So we work from the innermost part. So this is going to become x to the 1/3 power. Put that in a parenthesis like so. And then that's going to be to the 1/4 power, like so. So this is our inside part, and this is our outside part. So when we actually do the multiplication, this just becomes x to the 1/12. And you might notice that if you just multiply these together, you get the 12, and the exponent is just 1. Well, whatever way. But this is the better way to do it here. And there you go. And if you want to put it back in its radical form, remember, this is our index number, and it's x to the 1st. Now, here, this is often why we use fractional exponents, because we're trying to figure out how to do this. Well, if we put it in its fractional exponential form, this is going to be a to the 1/3 times a to the 1/2. And again, we have common denominators. It's going to be 6. We have to make this a 6, so this is going to be 2/2, 3/3. So this becomes a 2 plus 3, a to the 3 here, not 5, becomes a 5. A to the 5/6. So again, we're converting it to its radical, from its radical to its exponential form, and then we just add our exponents. There we go. Again, we're simplifying. This is example 4. So this is going to be x to the 3/2, converting this. This is going to be x to the 2/3, putting this in its fractional exponential form, and this is divided by x to the 2/5. Okay, so here we have to do a lot of fractional work here. Let's see if we can figure out what our common denominator is going to be. Well, this is all going to be over 1 because we're going to bring this up and subtract it here. So this is going to be x. Does anyone know what our denominator is going to be here? We have a 2, a 3, and a 5. I think it looks like a 30 here. So we have to make this a 30, so we got to multiply it by 15. So this is going to be 45 plus, multiply this by a 1 in the form of 10/10. And then we're going to bring this up here, and this is going to be 6 over 6. So this will be a minus 12 up here. So we do our adding, and that will be our answer. So when I get my numerator set up, I end up with a 53 over 30. So somewhat challenging here. And there's our 53 over 30, but they're saying that can be converted to a mixed number. It's all right. And if you want to put it back in its radical form, that would be x, which is to the first power, and then 30 as our index number, and then 23 under the radical, depending what they wanted. So this one was quite challenging. And I see I'm over my 20 minutes here by a few. And then using a calculator, and if you need to work a calculator for this, I'll be happy, of course, to show, and many of you already know how to do it. The idea is the calculator that you can use on your test, you want to be sure how to use those and to do this type of work here. And here what you would do is 125 caret, and then put 4 divided by 3 as a fraction, parentheses, enter, and that's your sign. Okay, we're not going to do the practice on this, and I think we've made this long enough.